So, dplyr is the recent tool from Hadley Wickham, who has written lots of packages that you probably use, like ggplot and reshape and plyr, which came before dplyr, as well as some development tools. I love dplyr, and I was really excited when them asked me to give this talk because it's a very specific tool. It has a pretty narrow scope, but the things it does exceptionally well, and they're things that you do every day. Like it's like, now that I've started using it, it's the core of what I do. Oh yeah, I wanted to say, so Gnome sends out that survey at the beginning of each quarter and asks, what would you like to hear talks about? And for my first 2 or 3 quarters here, I said, I want to know how to do the things I do in Excel in R. And I didn't even know well enough what I meant to formulate the question more precisely than that. But this is what I meant. I wanted dplyr a year before it came out. So dplyr. So first thing, dplyr is all about data frames. Where plyr use lists and data frames and arrays, dplyr is all data frames, and it really is basically just these 5 functions, these 5 verbs. And we'll go through each of them in order with some really simple examples. Here's a little data frame that I'm going to use to show how dplyr works, and then we'll do something on a real data frame. And so we have 8 objects. They each have a shape, a color, and an area. The first verb, filter, is to choose rows, and it's as simple as this. So the first argument to all of these functions is the data frame, which here is D. So filter D, where shape is circle, gives us those. Notice that shape doesn't have to be quoted. You can use arbitrary functions there in the argument. So suppose we were interested in, what did I do here, in small circles and large squares. You can put whatever kind of function you want in there. Pretty straightforward. And do feel free to interrupt me with questions at any point. I'd be happy to take questions. Select is much like filter, but to choose columns. So select shape and area will return those 2 columns. Note that they don't have to be quoted and they don't have to be concatenated. You can quote and or concatenate them if you like. You can also, much like indexing in base R, you can say, give me all the columns between shape and area. We'll return those inclusive. You can also say, give me all the columns except for this. And then you can also do pattern matching. So you can say, give me all the columns where the name contains this, or where they start with this, or whatever. Super straightforward, right? But stuff that we do a lot, and the syntax is just easier to write and read than base R. Arrange, again, really straightforward. So, the order function in base R, it drives me crazy how hard it is to just order a data frame by some variables, right? It's just way too much thinking to do something really simple. This makes it really easy. So take our data frame, arrange it first by shape, and then within shape, arrange by color. You can use the minus sign for descending order. You can also wrap area in DESC, and that will give it in descending order as well. Mutate. Mutate makes a new column, and the new column will have the same number of rows as all the other columns, of course, it's a data frame. And each row in the new column can be a function of other columns in the data frame. So here I'm going to make 3 new columns. New color is just sampling from the rainbow. Just for each row in the data frame, sample from the rainbow and give it a new color. For parameter, again, you can use arbitrary functions here, and you can refer to other columns in the data frame, and dplyr will look within that row. So for the perimeter that it's calculating in each row of the data frame, it's looking to the other columns on that row. So if it's a shape, then if it's a square, then the perimeter is this. If not, then the perimeter is this other thing. And then what I want to point out here is that you can also refer to columns that you just made in the same function call. So I just made this new column perimeter, and then I can calculate something else using that value again on each row. Okay. And then summarize is the only function that takes any real thinking about it all. And in order to use it in any meaningful way, we're also going to introduce this group by function, which does exactly what it sounds like. So you take our data frame and group by color. Still the same data frame, but now dplyr knows that it's grouped by color. Nothing's happened so far except that it's grouped by color. Then we give it some operation, some function. So you say total area is equal to the sum of area, and that's going to give us the area within each color. So the total blue area in the data frame and the total red area in the data frame. And that will always return, if you're using it right, it will always return a shorter data frame than the input. Is that all pretty clear? Pretty straightforward, right? Yeah.
Yeah, so everything, the presentation, we may even have the audio on the web page. I don't know. I haven't figured out how to. I think you can do that. Like all the Google things are archived. So yeah, the whole thing will be up there. The code will all be there.
So with that, we get to what is maybe the coolest part of dplyr, which isn't even originally from dplyr. So this is the pipe. This is a piping operator. It comes from the package dplyr, which if you don't get, you can look up. dplyr originally had a pipe of its own, and then Hadley said he liked this pipe better for several reasons, primary among them that you don't have to lift the shift key when you're typing it, which I agree makes it better. What the pipe does is it takes the output of one function and sends it as the input to the next function. You send something through the pipe, it becomes the first argument to the next function. So here I'm saying take D and then group by D, by shape by color, and then take the output of this and summarize where max area is with the maximum area. So let's see if you're paying attention. So how many rows is this data frame going to have? Remember, there are two shapes in the data frame, two kinds of shapes, and two kinds of color. So how many rows are we going to have in the output? Yeah, we'll have 4. We'll have 1 for each combination of shape and color. If there were other ID variables in the data frame that weren't included in the grouping, they would be aggregated over. Right? Any ID variables that aren't included in the group by will be eliminated. Okay, so that's cool, but that's a tiny data frame. The baby names data frame is 1.8 million rows. Oh, I've wrapped it here in this table data frame wrapper. Mostly all that does is it makes the printout nicer, so that if you just type the name of the data frame, you don't get the 5,000 row output. So it can take big data frames and display them in a friendly way. So suppose we wanted to do some common data analysis tasks. What were the most? Oh, right. So let me explain that data frame. So I forget what the source is, but it has, for every year from 1880 to 2013, by sex, it has the number of babies that were registered with every name. So suppose we want to know what the most common names were in the 1980s for each sex. And you can do it like this. We take our data frame, filter to just the 1980s, then group by name within sex. Summarize, we just want the number of individuals that were given each name within sex. Then what I've done here, I'm creating another column that will rank each name. So we've now got a row for each name within sex, and then this just calculates a rank order. Then we're only interested in the top 10 for each sex. So we filter to where the rank is less than or equal to 10, and then sort by sex and within sex by position, and we get that. So that's what we just did. That's what it would look like without the pipe. either that, or you could store to intermediate data frames as you go, which would clutter up your workspace. I think this is much easier to read. I love the syntax, right? It's like it makes a sentence as you go through it. Take D, then filter by this, then group it by this. Where here you don't have that, and you also have arguments separated quite a ways from their function, and you have to is this lined up with that? It's much more cognitively demanding, I think, to write this. It's also harder to read. I think probably less likely to introduce bugs with this syntax than with this. And then I leave it as an exercise to the audience to do this in base R and compare the syntax. I messed around with it a little bit. I wanted to put up what this would look like in base R. I haven't used the aggregate function before, and I played with it for like 10 minutes, and then I was like, no, I don't need to use this. I have summarize, but it's not particularly pleasant.
The other great thing about that is you can edit it very easily, because you can just pull out a line, which is if you had to do that from the other point, you have to track all of your parentheses and all of your argument locations. Whereas you can just comment out one line up in the top there, and that'll change your, that'll change the pipe in a very intuitive way.
Another thing that I really like about it is that as you're going, as things are wrong and you're trying to figure out what's wrong, it's really easy to just see, okay, what do we have at that point? Well, I haven't loaded anything here, and what do we have at that point? Okay, it's just sort of easy to navigate through and use. So, in summary, dplyr is easy to read and easy to write, which means it's less cognitively demanding for you, so you can put your head into the hard stuff. Also probably less likely to introduce bugs into code. It's database friendly. I didn't get into that because I don't use databases, but you can interact with all sorts of SQL databases using the exact same syntax that you would with a local data frame. And there are various tutorials on the web for how to do that. It's also fast. There are several bloggers have posted analyses of its speed. It's up to several orders of magnitude faster than Plyr. It's faster than base R, and it's nearly as fast as data table, which is sort of the gold standard for speed. And then this, mostly just for when we post it, there are several places to look for more information. So in the 0.2 update, Hadley introduced the do function, which allows you to call arbitrary functions within the dplyr stream. So if you needed to, you don't need it for very much, but if you wanted to create a model for each group within your data frame, you could do that with the do call. It's like dplyr was in Plyr. That's it. Any questions?
Yes. So you mentioned that it's first, though. Is that right in R already in C, or?
The back end is all in C.
Back in all C.
But you don't have to know any C.
And I think the very unique way is that to really use a unique way to use a pipe to write the SQL syntax. But how they did it? In Unix, I know I can write a pipe that is very fast to do the manipulation. But in the Windows system, so it does the same speed as in the Mac and Linux. In the pipe, the operation, the greater percent operation. Mm-hmm. So it does follow the same way as we use in Windows and in the Mac.
I don't know.
I'm
not a computer scientist.
The pipe is implemented in pure R, so in a sense, so it's riding on top. It's not using a pipe, a Unix style pipe. It's not feeding to a Unix system and coming back, or to whatever to your Windows shell and coming back. The whole pipe operator is written in pure R. So.
Oh, so you mean the operator is pure in R?
Yeah.
It's free.
Yeah.
You can use the pipe and any, like the other hand, you can use the pipe with any other package.
Right.
This is great.
Right.
Yeah, because what it does is it takes whatever is the output on the left, and it puts it as the first argument for the function on the right. So that was just a matter of getting the the syntax right, and the way R defines binary operators to do that. It's done in a very elegant way, and there's some good optimization behind it. But it's just a clever sort of R function.
What I'm concerned is that the speed. So if we write this way, and it does speed comparable to the we use in Mac Unix system. So I concerned with speed. So do you know a single in? Single in is it's like pseudo pipe. We can use a pipe in R. We can use pipe in Windows by single in, but the single in is just a pseudo way. It's very slow. It's not comparable to the Unix system. But
there are some things that with dplyr that have these set up that does lazy evaluation. So it's smart about the way it passes the pointer rather than all of the data between different functions, which is a big part of speed in R in general is lazy evaluation. So I think that's some of it, but I don't know how what the overhead associated with the pipe is. There's actually another pipe package called Piper, which is sort of the competing pipe package, which you can use in the same way. It's actually just two greater than signs rather than one, so that they don't beat each other, and they're sort of competing on trying to get more performance out of the pipe through lazy evaluation and things like that.
Another thing Noam reminded me of when he said that is that if you want to pipe something through and have it as the not first argument to the next function, you can use the dot as a placeholder. So if you need your data frame to be passed through and then be the second argument, then you use the pipe into the first argument and then enter a dot for the second argument. Yeah. Is there a divide function?
You can, well...
Give me a function. give me a function to do. Yeah. So, okay. Let's. So we could say really does work, I promise.
Yeah, I've seen it a little bit. So say if you have a multi-argument function, you can use it in the second position.
You can use the dot, and you can also you can do that sort of thing if you need a vector from the data frame that you passed.
Like if you're doing a linear model, you put the formula first?
Right. Right. So we could say, I don't model this way, but I think you're right. You and then if we wanted to, we could do like that.
If your argument has only one if your function has only one argument, you can just put the name of the function without parentheses here. So you could, instead of collab, just type summary, for the summary of the model.
Any other questions?
For some of the earlier functions you were talking about, like select and arrange, if you include more than just 2 variables, would you need to use the concatenate function, or would you just list them all out?
You can just list them all out. It might be. I think I would argue that it's more readable if you concatenate the names. But,
So also in the select function, so you will often contain some like function contains end with, start with, so embedded in the select function, or it's embedded in the arrange function. So what's the contents? Is the argument, or it's a function in a function or something? So
it's
in a slice or in a.
So I feel like maybe you come from computer science or something.
No. So
I don't know. I guess this is a
I've
function.
never seen this syntax before in other package. So
I can't tell you what it is, but I can tell you what it does.
Yeah.
So this looks through all of the column names for anything that contains the string sh, and it will return any column with a name that contains
yes,
sh.
but contains is not function, because I question mark and contains.
Everything's a function.
Yeah, but wait, but the contains is it's argument or something, because sometimes we write function, we mean some like something equals something to put into the argument, but the contains is a argument, or it's a what? I mean, it's not function, but
Well, I mean, it's an argument to select here, but looks like a function. It's probably
It's a
a
function within dplyr. It might not be a function like a universal function, but it's
Okay,
a
it's a
function
okay,
within
okay.
dplyr.
Okay, I see. Okay.
Right.
Good. Okay.
Yeah.
Probably just a wrapper.
Right. Okay, I agree. So it's in the box of the
Right.
the library.
When you sort with a range, does it preserve like order, particularly revolving around factors? It's always a pain when you plug in getting the factors
Good
in
question.
the right order.
Yeah, no, it doesn't change the order of factors going to ggplot. You still have to go through the whole levels rigmarole. Yeah, unfortunately. In ggviz, which is the successor to ggplot, I think it's sort of meant to work with dplyr, so I suspect that'll be the case in ggviz. All right, cool.